We're going to do the paper plate activity in class, so I don't have a video of that one. What we're going to do in this seminar is we're going to look at inscribed angles and tangents. This is MT10, LT4, and 5. I want you to describe the relationship between inscribed angles and the intercepted arcs, and I want you to use those relationships to solve problems. I want you to identify inscribed polygons and use those relationships to solve problems. I want you to describe the relationships between radii and tangents and use those relations to solve problems. And finally, I want you to describe the relations between central and circumscribed angles and use those relationships to solve problems. First off, an inscribed angle has the vertex on the circle. Remember I said we have different rules depending where the angle's at in the circle. This is on the circle. And if it's on the circle and I subtend that arc, notice it's half of the arc. A central angle is the same as the arc, so an inscribed angle is half of the arc. Or we could say it's twice as big as the angle. Central angle is the same. Inscribed angle is half the arc. So you could say an inscribed angle is half of a central angle. Now, our first theorem says if I have two central angles and they go through the same arc, those two angles have to be congruent because they're each half the arc. By the transitive property, they're going to be congruent. So let's apply what we've just learned. Maybe not learned, but just been introduced to. I want to find the measure of arc CF on example 1. CF is twice as big as my inscribed angle. Notice if I trace angle D, it intercepts CF. Since angle D is 40 degrees is half of what number? Well, that'll be 80 degrees. So we know the measure of arc CF is 80 degrees. Now if I want to find angle C is an inscribed angle. What arc does it subtend? Well, it subtends my 98 degree arc. So I know the measure of angle C is going to be half of 98, which is 49 degrees. Now, if I take a look at the measure of angle A in example 3, notice angle A subtends arc BC, so does angle D. So I know these two angles are the same. In other words, 5x minus 12 equals 3x plus 2. And we are just going to solve that equation. And when you solve that equation, let's subtract 3x from both sides. And I'll get 2x. Might as well get rid of subtracting 12, so I'll add 12 to both sides. 2x equals 14. Divide by 2. X equals 7. And then I want to find the measure of angle A. So A is 5x minus 12, so 5 times 7 minus 12, which will be 35 minus 12, which will be 23 degrees. Now, let's do a proof. We're given, you can see QR is congruent to ST, and PQ is congruent to to PT. Because of that, I know angle QPR is congruent to angle TPS. And I know angle angle QRP is congruent to angle TSP. That is our new theorem that we just learned, that we know equal arcs make, maybe I should say congruent arcs because we're not dealing with equations here. Congruent arcs have congruent inscribed angles. And then we're going to say segment QR is congruent to segment ST. That's from yesterday. Congruent arcs imply congruent chords. Now if we look, we've got angle, angle, side in those two triangles. And there's our proof. Nice 4-step proof. Based on our relationship, if you have an angle that inscribes a diameter, I know the diameter is 180 degrees, so that means I've got a right angle. Don't have to really know that theorem. We're just going to use our half of the arc. But it's a kind of a shortcut. Now, if I have a quadrilateral, any kind of quadrilateral, inscribed in a circle, notice, let's use angle K. Notice angle K subtends arc LMN. I've got this major arc here. So I know that's that part of the circle. If I look at angle M subtends the minor arc LN. Well, notice between those two of them, it's the whole circle. So what happens is the angles across from each other are half of 360, which is 180. And we know they're supplementary. And so I've got, and that goes for both pairs. The opposite angles, M and K, are supplementary. The opposite angles, L and N, are supplementary.